So hello everyone, this is a video training for the CytoFLEX Nano. With this cytometer, we can analyze nanoparticles as large as 1 micron in diameter and lower. When you first come to the instrument, you'll find it switched off like this. We're asking all users at the end of the day, if they're the last session, to switch off, shut down the instrument. We'll be running through how to start it up. First thing we need to do is check the fluidics caddy just underneath. On the left, you'll see the waste container. Please just check this, that it's not full. Give it a little shake. If it is full, please contact the platform staff to empty it. Or if you're inducted into the nearby lab, you can empty it into the sink there. And the next thing to check is the fluidics. So this is the fluidics fluid, sheath fluid here. We need to make sure that this is at least half full, so give it a bit of shake. Make sure there's some mildew in that. Okay, to turn on the CytoFLEX Nano, first we need to switch this at the back of the instrument. Long press on the blue light at the front so it goes green. And finally, we need to turn on the computer. So once the computer starts up, the password to log in is Beckman, all lowercase.
So once the computer started up, we just need to use Site Expert up here. Then we just need to click System Startup here. This will run for 6 minutes, during which time you can check the beads and prepare your samples.
So for running the QC, we will have these different bead products here, the scatterspheres, fluorospheres, and multi-intensity fluorospheres, which for running on the instrument, we keep in these little Eppendorfs. You can see these are just over 100 microliters full. That's perfect for running. If you find it at that volume or more, you can run them straight on the instrument. If they are lower than that, then we can just resuspend the beads from the tubes, use a vortex for this, put 4 drops in each of the relevant tubes, and undiluted. And the other thing I'd like to note is on the side of all the tubes, you'll see a lot number. This will be important when we are running the QC software later on.
Okay, because you can see here that the system startup has completed, and we can now go ahead and start to QC our instrument. Now, if you're not the first user of the day, it's likely that the person before you has already done the QC. You can check that here by just looking up the date for the QC section. You can see this report, nice green tick. This is passed for the user, and for the QC, that will be enough for you. We need to do this once every day. Someone's already done it. You don't need to do it again. For the sensitivity monitor, this is done either once a week, or if you're particularly keen to get very high sensitivity results, if you think your fluorescence might be low, for example, we can run this here. We can check again, just as before. We got a plus, no screen plus, so we would be, if this was run on the same day, we'd be happy to go again. Since neither of these have been done, we'll be starting them. The first thing to do is to start with the QC, and we need to enter in our lot numbers. So for the fluorospheres, as noticed before, you can find the lot number on the side of the box. Then we just need to hit Start. This will run through a preset program to QC the instrument. First starts by checking the background. And if it does find an issue with the background, as if it's too dirty and there's too many background particles being detected, it will warn you. If you do see this, don't continue. It will ask you if you would like to continue or stop. Do not continue. Stop this, hit backflush. This backflush button will be not grayed out. Let the black frost run for about a minute or so, and then start again and you shouldn't have an issue. Should get through the background quite nicely. This whole program takes about 20 minutes to run through all these. In a little bit, it will ask you to load the scatter spheres. Okay, so it's now asking for the scatter spheres, and I'm going to go ahead and load those.
Okay, so the instrument has asked for the scatter spheres in our QC, so I'm just going to load scatter spheres here. Just fit carousel like that. The lid fits between these little grooves in the top. So door.
And select OK. Okay, so now it's finished with the scatter spheres, and we can move on to do the fluorosphere.
Okay, so we just need to remove the scatter spheres and replace with the fluorosphere tube, the one marked with an F. Accepting that on the computer, and we can see it starts to take up the sample.
Okay, so the QC has finished and we have passed, and we can go on now to do the sensitivity. Again, selecting the lot number for the beads and selecting start. With this program, the first thing it asks for is the multi-intensity fluorospheres. So I'm going to go add them now.
Here I'm adding the multi-intensity fluorospheres, the tube marked with an M. Just as before, loading it, selecting OK.
Okay, it's finished the sensitivity monitor, and we can see this passed here as well. One thing to take note is the results down here, the gains for the different channels. Please go ahead and take a photo of these numbers here. We'll be needing them later on when we set up for our experiment. To start a new experiment, we'll just go up to File, New Experiment, create or find your own file here. Make a new experiment folder. I just use the date. A file name for the experiment. Okay, so this will open up a window here where we can see at the top the acquisition controls. Below that is the parameters that are measured while the particles or samples being analyzed. Next, we have the events display. This will set the preconditions for a recorded sample. Sample flow rate, we'd recommend that you run always at the slow settings. And we've got our sample tubes here. We'll be adding up for our experiment today. The first thing we're going to be running is milliQ. So double click and we can set on some milliQ. We're using milliQ today because that's the diluent that I've used for my test beads. Please just go ahead and use whatever diluent you're using here. It could be PBS. It's always good to use your diluent in the first run. It shows us how clean the system is and how clean your sample is, and it's a nice control for the background. The next thing I'd like to go do before adding the sample is starting a histogram. For this first milliQ, we're going to be setting up a lot of the acquisition settings that we're going to be using throughout. The first thing you want to be changing is the gain, where you can be adding in those gains from the sensitivity monitor. So just confirm that all the numbers you can see here are the same for what you had previously in the sensitivity monitor. So I'm just changing what I need to change. And then we want to go to threshold and change the manual threshold. It always defaults to 10,000. We want to change that to at least 350 at the beginning. And now you can go and load your water. Whenever you start running a sample, set the volume. You don't need to be exact to what you have, as long as what you've loaded is more than 100 microliters. The particles in the water have started to flow here. You can see this is our background result on the violet side scatter 1. This channel detects the smallest particles, anything that's smaller than about 150 nanometers. You can see our event rate is about 200 events per second. We'd like to get this to about 100. So we can just go ahead and increase the manual threshold until you reach a point that's roughly about 100 particles. Okay, there we have it. We're below 100 now, and I'll be using this threshold throughout the experiment. And while I'm at it, I'm also going to record a small file of this, so just 30 seconds for just for our records. Okay, that is finished, and we can just unload the sample. This takes a couple of minutes again, and at the end of unloading, the system also does a backflush before you can load the next sample. The next sample I'm going to run are tetraspec beads. So I'm going to add a new tube here. There's multiple ways to add a new tube. You can click this, or you can click up here. Relabel this. And I've made these beads into a dilution of 1 in 10,000. So it's always important to properly dilute your samples before running on the instrument. A concentration too high will lead to swarming and incorrect results. Whenever starting a new bead, a new sample, new preparation, please do a series of titrations to find the best dilution that gets the most particles through, but avoids swarming. Always start with your most dilute of the series of dilutions you've made. If it's too low, just move up to the next one. We do this so to avoid contaminating the instrument if you use a too high concentration of beads. So the unloading is finished, and we can add in our new sample. We'll go here and click Run. For this one, we're going to have a few more parameters to look at. So the first one we've got here is side scatter 1. That's the smallest side scatter in the violet. We also have side scatter 2 in the violet. The instrument can pick up side scatter for all the other lasers as well. So we've got the blue, the yellow, and the red. Just clicking on the labels allows you to select these. Another thing we want to look at is making a dot plot so that we can see the side scatter height versus the width. And we can use this to help tell us if there is swarming. It's always a nice thing when running flow to have a time element to make sure that the samples we are analyzing are being collected consistently over time. And we can also, with these beads, look at fluorescence. Okay, so here you can see the beads flowing. First up, we can see in side scatter 1, the 100 nanometer diameter tetraspec beads. It's actually a mix with half a micron size beads too, and you can see those appearing here in forward scatter 2. In the scatter 1 versus width, we can see that they're running smoothly. This is where we can start to see swarming. If you see a large population forming, so for example, just up in here, that can indicate swarming and that your concentration of particles is too high. We can see here we're running about 300 particles per second, so 200 particles per second more than in our background. And with time, you can see that we've got a nice signal that is consistent throughout time. If there is an issue, sometimes you can see a problem here with time where a dip or a loss of signal occurs. And then in our side scatter channels, we can see different populations of beads. And we can start to do some population analysis by gating on different population types, and we can relabel if we would like. Make another one on the larger bee population. If need be, we can make sure we're only selecting the most non-swarming particles here, and we can even select those that we want and leaving out any others. If I open up the hierarchy plot, you can see that here, everything is all straight out of all events. If I was to change this to only click those, now we've dropped another layer in the hierarchy. Now, once you've got your parameters set, we can then start collect data. How much you collect is depending on your needs and your experiments. For my example here, we could just run for 30 seconds. Or if you needed to run for a set number of events recorded, you can set that here, say 10,000 events, and then from which population you want. Now, if all the events will be collected, it'll just the data will just keep running and keep collecting until the set number is reached. So that is in these ones here. If I hit record, you can see we're tracking the numbers here. And then once this reaches 10,000, the acquisition will stop. Next, I'm going to show you what swarming looks like. So we'll start a new tube, and what we're going to use here is one that's actually 10 times more concentrated than the previous specs. So here you can see a population that is much larger than before. We're running many more cells in live population. This is a clear sign of swarming. If you see this, stop the run. You're not collecting good data, and dilute your sample further. So there's several ways to clean the instrument. The first is to try a backflush. This is the fastest way, most simple. You can see if that works. If that doesn't work, the next step that you can try is the onboard clean. This one runs for about 8 minutes. If it's still dirty after that, the next you can try is the customized baseline clean. Now this is much longer. You can see here with these current settings, it will take 34 minutes to run this clean. Sometimes that's what's required when things are very dirty. You can always change these settings to get it a little bit faster. Okay, now once you've finished with the instrument, if you are not the last user of the day, all you'll need to do is, before you finish up, run an onboard clean for the next user. If you are the last user of the day, it's then down to running a shutdown. Before doing that though, we need to transfer our data. And when looking at our files, there's two different types. The XITN files, that's what works here in the software. What you might be more commonly using is Flojo. For those, you'll need to use the .fcs files, which is found in the associated folder. To transfer the files, we can use the MediaFlux data mover. And then in shutting down, we simply go to System Shutdown, and we've got two different options here. We normally go with the long-term soak if you're the last user of the day. This takes 8 hours to run, so now all you need to do is pack up your samples, clean the desk, and you're all finished.